So today we're going to look at geometric series, but before we do that, you're going to do a warm-up reviewing some of the arithmetic series stuff we've done over the last 2 days. I'd like you to take a few moments to work through the 11.4 arithmetic series practice that you should have received, and when you're done, you're going to submit your answers through the Edpuzzle video, and I'll show you my work, and we'll see what's going on. Okay, so starting with problem 1, please submit your answer. So in problem number 1, it's an arithmetic series. I need to go and find my 40th term. Well, the 40th term is the first term, plus common difference is 10 times 40 minus 1. 392 should be your last term, your 40th term. I'm going to go to my series formula. That is 40 over 2 times first term is 2 plus last term is 392. You're going to get 7,880. Please submit your answer for problem number 2. Problem number 2, my 10th term is negative 43 plus common difference here between each term is 3, so 3 times 10 minus 1, that's negative 16. I'm going to go and use my series formula. That's 10 over 2 times first term is negative 43 plus last term is negative 16. We're going to get negative 295 for that one. Problem number 3. Please go submit your answer. So my last term here is 644.6. My first term is 15.3 plus common difference. If you do 37 minus 15.3 and then 58.7 minus 37 and so on, you're going to get 21.7 times 30 minus 1. That is 644.6. I'm going to go use my S sub 30 formula. 30 divided by 2. First term is 15.3 plus last term is 644.6. You're going to get 9,898.5. Problem number 4. Please go submit your answer. So it's an arithmetic series, and there are 20 terms over here. 20 minus 1 plus 1 gives me 20 terms. For the first term, you're going to plug in your lower limit of 1. So 7 times 1 minus 3 is 4. For your last term, you're going to plug in 20, your upper limit. 7 times 20 minus 3 is 137. And then the sum of our 20 terms is 20 divided by 2 times first term is 4, plus last term is 137. That will give you 1,410. Number 5. I guess I'm just going to show you my work for number 5 because I didn't think to pause the video here. Number 5, there are 23 terms. Top minus bottom, 28 minus 6 plus 1 is 23 terms. The first term, you're going to plug in not 1, but rather plug in your lower limit of 6. 10 times 6 minus 4 is 56. Your last term, 10 times 28 minus 4 is 276. The sum of your 23 terms, 23 divided by 2. First term is 56 plus last term 276. Your formula will give you 3,818. Please go send in your answer for problem 6. There are 14 terms here. The top minus the bottom plus 1. 18 minus 5 plus 1 is 14. There are 14 terms. The first term is 7 minus 6.5 times 5. That's negative 25.5. The last term, 7 minus 6.5 times 18, negative 110. Now I have everything I need to plug into my formula. I'm finding S sub 14, the sum of those 14 terms. 14 divided by 2 times first term is negative 25.5, minus last term is negative 110. Plus last term plus negative 110. You're going to get negative 948.5. can you please get out your notes and open up to section 11.5, which is page 17 in the notes. So today we're going to look at geometric series. The formula is a little bit more complicated to use, but in some other ways it might be a little bit nicer because I'm not going to have to use a separate formula to find like the last term first. First of all, the formula. A1 times 1 minus r raised to the n, in parentheses with the n inside the parentheses, divided by 1 minus r. A sub 1 times 1 minus r to the n over 1 minus r is our formula. Make sure you get that copied down. A1 stands for our first term. R, which shows up in two different places, in the numerator and the denominator, is our common ratio. And n is the number of terms. Where's the formula come from? I think we're going to skip over that. It's not a fun story like the arithmetic series formula with Gauss and all that. It's more just kind of some algebraic manipulation. I don't think it's too insightful. I'd rather just spend our time focusing on how to use this formula. So let's take a look at that first example. I want to use the geometric series formula to evaluate that sum. Now clearly I could just add things up, and I think we'll do that in a moment to check things, but I'm going to try to use that new formula, S sub n equals A1 times 1 minus r to the n over 1 minus r. What is your A1? A1 is your first term. A1 is 3. By the way, 1, 2, 3, 4, 5, 6. I'm trying to add up 6 things, so I'm finding S sub 6. That is 3 times in parentheses. 1 minus. Now, what is your common ratio? What are you multiplying each term by? Common ratio should be 2. So I'm going to do 2 raised to the, while I'm finding the sum of 6 terms, 2 raised to the 6th, divided by 1 minus the common ratio, 1 minus 2. This is the formula. It's going to take a little bit of work to type into the calculator, but the good news is I don't need to use a separate formula to first find the last term. Okay, let's type things in. The way I'm going to do this is I'm going to do this in 3 steps because it is very easy to make some small mistakes when you type things in here and get a very wrong answer. I'm going to start by dealing with what's inside those parentheses. I'm going to type in 1 minus 2 raised to the 6th power, and then I'm going to push enter. I've got negative 63. I'm next going to multiply that by 3, and by now I've taken care of the entire numerator. Then I'm going to divide by, in parentheses, and the parentheses here are really important. In parentheses, I'm going to divide by that denominator, 1 minus 2. That's going in parentheses. I'm going to get an answer of 189. If you don't use the parentheses when you divide, it's like I'm dividing by 1 and then subtracting 2 from the answer, which isn't what I want. I'd get a very different and wrong answer. The sum of these terms should be 189. If I actually check that, add them up, yep, I'm going to get 189 for my sum of those 6 terms. I want to show you 2 variations on this. Again, I think the tricky part is just going from here to our final answer, making sure we're typing in things properly. So I'll show you a couple things in the next example. S sub 12 for that series. Okay, so S sub 12 equals, what is A1? A1 is the first term that I see, negative 43, times 1 minus. What is your common ratio? Common ratio here is negative 3. Go do 135 divided by negative 45. Negative 405 divided by 135. 1,215 divided by negative 105. You're going to get negative 3. Now, my formula says 1 minus the common ratio raised to my power. I am going to say negative 3, but I need to put the negative 3 in parentheses. This is going to be important, and then I'm going to raise that to the 12th power. I'm going to divide my answer then by 1 minus negative 3. It is very tempting, I think, to want to change these things into two positives, double negatives, make a positive. You are not allowed to do that because of our order of operations. Order of operations says I need to deal with my power first. And in fact, when you do negative 3 raised to the 12th, you'll no longer have a negative there. It will end up being 1 minus some positive number. So don't leave anything. I'm just going to leave it the way I have. And what you need to realize is anytime your ratio is a negative number or a fraction or something like that, you need to put it in parentheses. Now, to go to the calculator, we are going to first type this thing in, get an answer, then multiply that answer by negative 5, then divide that answer by, in parentheses, 1 minus negative 3. You see if you can type it in and get an answer. Okay, so 1 minus, in parentheses, negative 3 to the 12th, negative 531,440 times negative 45, divided by, in parentheses, 1 minus negative 3. 5,978,700. That should be your answer. And again, what we're finding is the sum of all of these numbers, the first 12 numbers in that pattern. Last example on this page. Find S sub 5 for that sum. Okay, what's A1? A1 should be 1/3. 1 minus, what is your common ratio? Common ratio is 1/3. If you're not seeing that, so first of all, ask yourself 1/3 times what gives you 1/9. Yeah, 1/3. 1/9 times what gives you 1/27. 1/3. You could also do the division on the calculator as long as you're careful with your parentheses. 1/9 divided by 1/3. Yeah, that's 1/3. 1/27 divided by 1/9. Yeah, that's 1/3. I'm going to raise this to the 5th power. I'm going to divide by 1 minus 1/3. Now, I want to see if you can go to the calculator, type things in. Make sure you put the 1/3 in parentheses the way I wrote it. Again, if the ratio is more involved than a positive whole number, put it in parentheses when you do your power. You're going to do this. You're going to multiply by 1/3. You're going to divide by, in parentheses, 1 minus 1/3. See if you can do this and see if you can make your calculator give a fraction answer. One minus 1/3 to the 5th power. Then I'm going to multiply that by 1/3. Then I'm going to divide by 1 minus 1/3. This is giving me that decimal. I'm going to convert that to a fraction. 121 over 243 should be your answer there. Turn the page and we're going to look at some sigma notation. The first thing we have to figure out is when will a series in sigma notation be geometric? All three of these are geometric. And what you should notice is here the variable is in our power. In fact, this is like an exponential function when our variable is in the power. Any series in the form the sum as I goes from some number to some other number, a times b to the I, is geometric. Any time that our variable is in the power, and I'm saying I, it could also be I minus 1, I plus 1, any of those things. Get that line in your notes, please. So I want to see how I can use this idea combined with my geometric series formula to figure out this sum. It's geometric because my variable is in the power. And I know there are 10 minus 1 plus 1. There are going to be 10 terms in this thing. Now, I want to write out the first couple terms in my series. This is not how we're usually going to do this, but I want to show you this here so we can kind of create the rules for ourselves. If you plug in the lower limit of 1, you're going to get 6 times 2 to the 1 minus 1. That's my first term. Then plug in 2, 6 times 2 to the 2 minus 1. That's the next term. 6 times 2 to the 3 minus 1. 6 times 2 to the 4 minus 1, and this will keep going for a while. I think that's good enough for me right now. Again, this is not how we're usually going to do this. I'm just trying to show you something. 6 times 2 to the 0, plus 6 times 2 to the first, plus 6 times 2 to the second, plus 6 times 2 to the third, plus dot, dot, dot. Then we need to figure out these 4 things. Whoops, hold on, not plus. 6, 2 to the 0, that's just 1, so 6 times 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. This is going to give me 6 plus 12 plus 24 plus 48 plus dot, dot, dot. Okay. I think I see the things that I need to see to be able to use my geometric series formula. And just to write that down again, S sub n equals a1 times 1 minus r to the n over 1 minus r. I am trying to find S sub 10. S sub 10 equals, what is your a1? a1, that first term, is just 6. To find your a1, again, we're not usually going to write out all these things, but we will need to go through the work of plugging in your lower limit to find a1. Times 1 minus, look at the series. What is your common ratio? Common ratio here is 2. Every time I'm multiplying by 2. So I'm going to say minus 2, hold on one moment, minus 2 raised to the n, to the 10th. And I'm going to divide by 1 minus 2. Now, go back to your series formula. Do you see a 2 in there? Yeah. That thing, that base of the exponential function, the thing I'm raising to my variable power, will always be the common ratio. I want to go back to the beginning where I said a times b to the I is geometric. B is the common ratio. Now, I know you also see a 6 there. It's not really fair, though, to say that that other number will be the first term. In this case, it was. But in general, we do need to go and plug in that lower limit to find our first term. Well, now that we have all this, go to your calculator, do it in the 3 steps, and tell me what S sub 10 is, please. I'm getting 1 minus 2 to the 10th. I'm multiplying by 6. I'm dividing by 1 minus 2. That's going to give me 6,138. Next problem. This is geometric because my variable is in the power. How many terms are there? There should be 6 minus 0 plus 1. There should be 7 terms in this series. Okay, to find the first term, we need to go and plug in our lower limit. Plug in our 0 for I. you're going to get 4 times 3 halves to the 0. Please tell me what the first term is. Well, 3 halves to the 0 is 1, so this is 4 times 1. Your first term is 4. What is the common ratio? Remember our new trick. What's that ratio? The ratio is the thing I'm raising to my variable power. It is 3 halves. So now if we go to use our formula, s sub 7 equals the first term is 4 times 1 minus, the common ratio is 3 halves, raised to the 7 over 1 minus 3 halves. Make sure the 3 halves up top is in parentheses. You plug it in, and I'd like you to try to get a fraction answer. If you get the calculator, won't give a decimal, but I think you can try to get a fraction for this. One minus 3 halves to the 7th. I'm going to multiply by 4. I'm going to divide by, in parentheses, 1 minus 3 halves, and I'm getting 128.6875. When I do math, enter, enter, or just the convert to fraction button, you should get 2,059 over 16. Last one with the sigmas, then we'll do 2 word problems, and then you're going to do some practice. This is geometric because my variable is in the power. How many terms are there? There should be 12 minus 1 plus 1. There should be 12 terms. Please find the first term. The first term comes from plugging in the lower limit. It is negative 2 raised to the first. That's negative 2. Tell me the common ratio, please. Common ratio should be negative 2. We're going to get s sub 12 equals the first term is negative 2 times 1 minus negative 2, again in parentheses, raised to the 12th over 1 minus negative 2. Be careful with your parentheses, type it in, and submit your answer. I'm getting 2,730 for that one. Last thing we're going to look at are 2 quick word problems. Turn the page. First word problem. This month, Julia deposits $400 to save for a vacation. She plans to deposit 10% more each successive month for the next 11 months. I want to know how much total will she have saved after the 12 deposits. We've seen things sort of like this before where I've asked you how much is she depositing in the 12th month, but now I want to know the first month plus the second plus the third plus add up all those dollar amounts. We're first asked to write out the first few terms of the series. In the first month, you're depositing $400. Okay? The next month, we're depositing 10% more. Well, what I could do is I can find 10% of 400. I'm going to multiply 400 by 0.1 and add that to 400, which means in the second month, we're really going to deposit $440, 10% more than the first month. There's a better way to do this. Rather than saying 10% and then add that to the 400, we could just say the second month we're really depositing 110% of what she deposited in the first month, which would mean me doing 400 times 1.1, 440. If I do that again, I want to find 110% of 440. I'm going to multiply that by 1.1. I'm going to get 484. Again, if you don't like that, I could say, let's just find 10% of 440. 440 times 0.1. Add that to 440. You're going to deposit $484. And I think that'll be good enough. This is going to keep going. This is a geometric series because each term is some number times the previous term. I want to find the sum of my 12 terms. I'm going to take A1, which is 400, times 1 minus. I need to find my common ratio, what you're multiplying by each time. I could go and do my second term divided by my first term, 1.1. Third term divided by the second term, 1.1. And I feel like this should make a lot of sense because, again, we talked about it's like multiplying each term by 1.1 to get the new term. I'm going to do 1 minus 1.1 raised to the 12th. And I'm going to divide this by 1 minus 1.1. Now, I'm going to go and type this in. Actually, you can go do that. This is a money problem, so your final answer should be rounded to the nearest cent, 2 decimal places. Go type it in and submit your answer. One minus 1.1 to the 12th times 400 divided by 1 minus 1.1. I'm getting about $8,553.71. This is not how much money she deposited in the 12th month. This is all 12 of those months added together. Let's look at one more. The first year, a toy manufacturer introduces a new toy. Its sales total $495,000. The company expects its sales to drop 10% each succeeding year. Find the total expected sales in the first 6 years. Okay, well, I'm going to write out the first few terms of the series. I know initially they are making $495,000. The second year, they're making 10% less. Well, I could find 10% of 495,000 and then subtract that from my 495,000, and I'll get 445,500. But I think the easier way to think about this is, rather than making 10% less, you're making 90% what you made the previous month. 495,000 times 0.9. We are going to get 445,500. Do it again. Let's multiply where they're making the second year by 0.9 to figure out what they're going to make the third year. That's going to give me 400,500. And I'm just going to say plus dot, dot, dots. Use a series formula to find the sum. Well, this is a geometric series. What's the common ratio? What are you multiplying by each time? We're multiplying by 0.9. That's how I created those. But also, if you go to do your division, this divided by this, that divided by that, you'll get 0.9. I now want to find the sum of those 6 terms. I'm going to take my starting term, 495,000. I'm going to multiply by 1 minus. My common ratio is 0.9, and I'm going to raise it to the 6th power. I'm going to divide by 1 minus 0.9. Same 3 steps we've been doing before. Do your parentheses, multiply by that, divide by this in parentheses, type it in, give a decimal answer, round it to 2 places because it's money. I think it's $2,319,367.05. And you might be a little confused because the dollar amounts are going down, so you think it would be a smaller thing. But remember, that's not what I'm trying to find. I'm not trying to find how much was deposited in the 6th year. I want to figure out the sum of all 6 of those years. So yeah, you add those $6 amounts together, you'll get something in the 2 millions. What you are going to do now is a little bit of practice with this through Delta Math. You're going to need to take out some scratch paper, and if you don't have any, grab some from the side, put your name on it, and you will be submitting the scratch paper at the end of the period. Go back into Google Classroom, find the top yellow dot in Unit 11 that should say Delta Math Geometric Series, and work through those 10 problems. If you finish that and have time to spare, you can spend the rest of the period working on the homework, which will also be posted in Google Classroom. I will see you next class.